Okay, back into it. Let's go. Let's get this program back up. All right. What are we doing? Right, fixing this. Yes. I'll do it inline first. I think that makes sense. Actually, I'm curious. This doesn't compile, right? It does not. This should just be output boxes. I do not have an output boxes. Congratulations, you played yourself. Struct, output boxes, maybe? Draw output box declared here. Ooh. Declared where? Wait, what? You lie, sir. You lie. What in the goddamn? Is that not how this works? If I update widgets, it should rebuild. Updated. That's interesting. On line 34. Oh. Excuse me. Excuse me, yes. And this should be sharp pointer text, I guess, and size t text pos. Is it pos? I think it might be pos that I'm after. Like that. Okay, and then that should break widgets. Right, this is a char. This is, I think, still a void. Okay, very good, very good, very good, very good. So it did break widgets. All right, cool. 528. Params text. Yeah, you2. Params. Okay, very good. Yes, params. Yes. Good question. I guess I only need it once I get down here. So I guess I can go params equals boxes pointer index. Right? My problem. You see, Doc. What my problem is that means when we hit the deleted button, like mentioned before, it'll be updated next frame. But if we hit the add button, it's actually going to be updated this frame. Because when we hit the add button, we immediately update box's length. Yeah, I am doing stuff here. To do, I guess. To do. So what we could do is update later, I guess. Just update it at the end. Do we update these at the end of the function? Otherwise, add updates this frame, delete next frame. What the fuck? I guess there's one interesting thing about this editor is if you accidentally hit the wrong key, just like some random arcane magic happens. Luckily there is an undo key, so we're Gucci. All right, let's fix up this. We're gonna be deleting all this anyway, but sure. What else do you want me to fix? No VO. No VO indeed. That's very astute. Do we need to do other stuff? Yes, we do. There is no VO. No VO. Yeah. Do we make sure we record the output? Params A out equals AO. That's interesting. So we're going to allow video output with no audio. I'm a very interesting coder. Oh shit, is that gonna work? Does that need to be initialized in any way whatsoever? Pipe video, please. No, it looks like we set it all up. Yeah, okay, brilliant. What I like to see. Fuck, I'm the greatest programmer who ever lived. V out equals VO. Okay. What else you got for me? That's probably fine. Oh shit. Yes. Very true. Very true indeed. We don't have a structure which stores our video outputs. We just have this global array. I do not want to fix that because I cannot be bothered. But I have to. What am I gonna do? I could just go through the entire array and find the first one that's not valid. It probably means I need a lock around it. Probably. Do I already have a lock for it? I do not. But we do set valid as the very last thing. Although this can be reordered, right? I need a memory barrier here or something. Like this needs to be the last thing. Like this can't be reordered. This is important. How do I do that? To do. This actually probably should be everywhere in the file. But we'll put it here for now. To do, all valids need to be... what's the actual order? It's not consistently ordered. It's, there is a relaxed ordering for it, but what's it called? Store release, I guess? This is a store release, is that right? Fuck, I can never remember how this shit works. Store release memory ordering. Probably, but I think ARM has a diagram from memory. Yeah, so load acquire, accesses cannot cross a barrier in one direction. So if we put a load acquire in, it can reorder stuff from above. What I don't really get is, like, how is that different? Like, if you can just move everything up here to be down here, how is that different from moving everything here to be up there? I don't really quite understand how this works. Like, it feels like if you just chuck a load acquire into your program, nothing changes. Like, yeah, okay. this can't be moved up here. But all of these can be moved down here. I guess that's not strictly true because there's other things in a regular program than loads and stores. But it feels like this is pretty weak. Anyway, yeah, store release is the one I want, I think. No, I want load acquire. Wait, what? No, wait, do I want both? Because the thing that I want is this needs to be the very last thing that happens. So maybe neither store acquire nor load release are good enough. Because like all this shit can happen whenever. I don't care what happens up here. It's like this needs to be the last thing. Oh, I just do both? No, wait. What? Sequentially consistent? Regular accesses can cross the store barrier, but loader cannot. When a load acquire appears in program order after a store release, the memory accesses that are generated by the store release is observed before the ones by the load acquire. Yeah, I don't know. This is not very helpful. The fact that it can just rearrange like almost anything anywhere. Like B can go all the way down here. Like what the fuck? It's really only the stores that I'm worried about. That in particular, that last store. The stores need to be. A load operation with this memory order performs a consume on the affected memory. No reads or writes in the current thread dependent on the value currently loaded can be reordered before this load. Not what I want. No reads or writes in the current thread can be reordered before this load. Also not what I want. Oh, you can only do this on an atomic. I guess that makes sense. No reads or writes in the current thread can be reordered after this store. This is what I want. I want to release. All writes in the current thread are visible in other threads that acquire the same atomic variable. All writes in the current thread are visible in other threads that acquire the same atomic variable. I see. Writes that carry a dependency into the atomic variable become visible in other threads that consume the same atomic. I see. But this is C++ though. C ensure ordering of stores. Okay, of loads and stores. Okay. Not C++ though. Is this what I want? A memory order barrier? C memory order barrier. Oh, C memory order barrier. Memory barriers in C. What do you know? Instructions shouldn't be reordered across the barrier. If you have C11 support, Yeah. Okay.